All right, so today our goal is to graph two linear inequalities. So basically we've been graphing inequalities, but now we want to be able to graph two of them on the same coordinate plane. So that's the idea. It shouldn't be too crazy, but definitely a little bit more challenging. You're going to want to probably use really light shading or colored pencils. So colored pencils are going to be pretty helpful in this situation. Let's just talk a little bit about something kind of cool. So I'm just going to draw a quick coordinate plane here. Let me see if I can pull one from my pictures and stuff. Here's one. Okay, so here's a coordinate plane I just pulled. And I'm going to graph a couple of things. I'll graph this. And I'll graph this. And I'll graph a couple more, just to get a couple different colors here. And then, what did I not use? Blue? Okay, so let's pick some points that would be a solution to this system. If I was going to graph this, and I was calling this a system of inequalities, and I graphed, it seems like I graphed to the left of the red line, which is really below, by the way, because we have the positive numbers over here and the negative numbers over here. So left is below when you have a vertical. I graphed above the green, above the blue, and below the purple. So those are my boundaries. Think about some points. Okay, I'm going to maybe talk about this in class, but think about some points that are on the interior that are solutions to all of those lines, and then think about some that are not solutions, okay? So is 0, 0 a solution to that system of inequalities? That's something you want to start thinking about. So today, two inequalities at once. That's the goal. So these are the notes you're looking at, I believe, and let's see what we can do. So a combination of graphing inequalities and system of equations is kind of what we're dealing with. We want to have two inequalities that we graph and shade. In this class, we don't go much more intense than that. So for today, I'll just keep it with a simple one. It's already in form, ready to graph. Let's just do two different colors. So we'll do green and we'll do blue. We won't go Christmas theme right now. So if we look at that green equation or inequality, it starts at -2. It goes down 5 over 3. We don't really have space for down 5 over 3, but it would look somewhere like this. So instead I'm going to go up 5, 1, 2, 3, 4, 5, and then back 3. And that's that inequality, and it's a dotted line because it's not, there's no line underneath it. And we would like to shade above that line, so I'm not going to go crazy here. I'm just going to shade like that, okay? Nothing crazy. That's what our shading will look like. If you're using pencil right now, shade it really light with the pencil. Just hardly get anything on there, just so you can barely see it. Now we want to look at that next one. It's at +2. And it's down 1 over 3. Okay, and it's also a dotted line. So it looks like this. And I want to shade above that line, so I want to look like this, basically. I'm going to go the other direction. Okay, I want to hit the line, but I don't want to go past it. You notice that? It gets a little cluttered here. There's a lot going on. Now the question becomes, where did I shade twice? That's the most important thing to understand. And I think, used to be able to get like a highlighter on this thing. Alright, oh well. So what got shaded in twice? Well, anything that was above both lines. This is the region that got shaded twice. So if you have something and you've already colored it in, and now you're coloring it again, you're shading it twice, that's where you want to kind of go crazy. Make it super dark. So what will happen is you'll have one super dark section. You'll have two sections that are like not so dark. They're just like colored in a regular amount, and then you'll have one that's not colored at all. So the question becomes, what points in each of these areas, what is this really about? It's about points. So would this point work in both inequalities? Would it work in the green? Would it work in the blue? Would this point work in both inequalities? Would it work in both the green and the blue, or neither, or one or the other? Would this point work in both, just one, or neither? That's the question you got to ask yourself. So take those points maybe and plug them in. See if it's true or false. That's what's happening. So systems of inequalities, basically just taking the same thing we've been doing, but we're now doing two inequalities at once. So now you tried this problem, okay? Don't forget about how to graph this one. You might need to look back, but its x is greater than 4. So think about whether that's it's a special type of line. And remember, if you are, well, just scroll back like a couple minutes. I talked about this kind of problem. So give that a shot. Good luck. Okay, so that's your now you try. So make sure you try this problem. Give it a shot, and we will go on to a couple of different things. So here we're trying to match the linear inequality. So if we look at that first inequality, we have the blue and the red inequality, I guess you could say. And we want to look at which ones go together, I guess, for lack of a better term. So if you look at the first equation, the first inequality, because the whole goal here is to be able to not only graph the inequalities, but take the graph of the inequalities and reverse it into the equation, the inequality, I guess. Take the graph and turn it into the actual inequality. So, okay, sorry. We want to get this into y equals mx plus b form. Once we do that, we'll notice pretty quickly that there's a y-intercept of 4. It's got a slope of -2, so a is its match. The second inequality is a little harder to tell. If you do a little work, you'll see it as a y-intercept of 0, and you'll match there. The bigger point here is to be able to go both ways, and I don't know if this does a great job of that. Maybe what we should do is take a second and just draw out a graph and see if we can write the equation from a graph. So it's the reverse of what we've been doing. We've been graphing inequalities. We want to take now a graph and write an inequality. Exact thing backwards. I'll get you a sketch here. Oh, sorry, I'm writing an equation here, so let me get rid of that actually. And I will draw you a coordinate plane. Alright, so you got your coordinate plane. We'll just say up 4 here. It's our dot. Then we'll say this is over 1, 2, 3. We'll put a dot there, down 1, 2, 3, 4. Put a dot there. We'll make this line dotted. So think about it. It's a dotted line. It's colored in up above. So think about what you would start your inequality with. How would you write your inequality for starters? Well, I would say y is greater than, but with no line underneath. So y is greater than, but with no line underneath. And now all you need to know is the slope and the y-intercept, and you are home free. So pay attention. You've got a slope of -4. It's down 4 over 4, down 4 over 1, and it starts at +4. The y-intercept is at +4. So hopefully that makes sense to you. Last but not least, we want to be able to take x, y points, right, and plug them into inequalities to see if it's a solution to the system of inequalities. That means it's got to work for inequality 1 and it's got to work for inequality 2. So taking the x and plugging it into inequality 1's x and the y and plugging it into inequalities 1 with y, we would have 5 is less than 3 times 2 is 6. So that would be yes, a check mark, because 5 is less than 6. Now we'll go with a different color, and we'll do the same thing. We'll plug into inequality 2 and see if it's another yes. So that would be 5 is greater than or equal to 3 plus 1. 5 is greater than 4, or greater than or equal to 4. So this is a yes. It worked both times. Got to work both times. When we look to our next inequality, we got to see if it works both times, one time, or never. So that's what we're looking for. So I'll just do it kind of quick. I'll just do it in my head. We'll have 0 for our y is less than -4, and that's a no. I didn't show all the work there, but as soon as you get a no, it's got to work in both. So if it doesn't work in one, it's automatically not a solution to the system. So this is not going to be a solution to the system right then and there. So your job is to try this again. You see the two ordered pairs. For number 1, take that ordered pair and plug it into those two inequalities. For number 2, do the same. If it works both times, it's a solution. If it doesn't work one time, it's automatically out. And that is it. So good luck. Do the best you can, and I'll see you soon.